Let's begin by talking about what we really mean by the equality sign in mathematics. In this lecture, we will focus on the equality of two real numbers. As we venture further into mathematics, we'll extend the definition of equality and compare other objects such as functions and matrices. An equality is a statement which is true if the combination of symbols on the left-hand side represent the same real number as the combination of symbols on the right-hand side. For example, when we write 3 plus 1 is equal to 4, what we mean is that 3 plus 1 and 4 are two different names for the same element in R. A statement such that A equal to B is true if A and B represent exactly the same real number. Suppose that A is equal to B. For example, if A is equal to 5, then B must be equal to 5 as well. Now consider the statement A plus C is equal to B plus C. Given that the first statement is true, will the second statement necessarily be true? The answer is yes, since A and B are simply different names for the same real number. A plus B must be equal to B plus C. But the opposite holds as well. If A plus C is equal to B plus C, then no matter what C is, A must be equal to B. We say that the statement or equation A is equal to B is equivalent to the statement or equation A plus C is equal to B plus C. One of them is true if and only if the other one is true. We write this using an arrow pointing in both directions. You know this from basic algebra, as you can add any number to both sides of the equation without changing the equation. We use this result repeatedly when we solve equations. For example, to solve the equation x minus 3 is equal to 5, we add 3 to both sides, giving us the solution x is equal to 8. Similarly, you can subtract any number from both sides of an equation. This follows from the previous result, since subtracting C is the same thing as adding the additive inverse of C, or minus C. Multiplying both sides of an equation by the same number will also create an equivalent equation, as long as you do not multiply by 0. For example, 3 equal to 4 is a false statement. However, multiplying both sides by 0 will make it true. This is why we must exclude 0. You can also divide both sides of an equation by the same number except for 0. This follows from the third rule, since dividing by C is the same thing as multiplying by 1 over C. Moving on to inequalities. Given an inequality such as A less than or equal to B, we can add the same number to both sides without changing the inequality. These are called equivalent inequalities. The result is also true for the other three inequalities: the less than, the greater than, and the greater than or equal to. Obviously, you can subtract the same number from an inequality as well. However, multiplication of both sides of an inequality introduces an additional dimension. If you multiply both sides of an inequality by a strictly positive number, then you will create an equivalent inequality. However, if you multiply both sides of an inequality by a negative number, then the direction of the inequality will be reversed. Less than or equal to will go to greater than or equal to, while less than will go to greater than. To see the reason for this, 2 less than equal to 4 is certainly true. However, If I multiply both sides by -1, I have -2 on the left-hand side and -4 on the right-hand side. -2 is to the right of -4 on the real number line, so -2 less than or equal to -4 is false. However, if we replace the less than or equal to sign with a greater than or equal to, the inequality will be true.